All right, the next thing we're going to review is factoring. The reason we're reviewing it at the beginning of the year is because, or the beginning of the semester, really, is because we're going to use it all semester. It never goes away. It shows up all the time. So you want to get used to seeing it now so that it doesn't freak you out later. So this is what the top of your notes looks like. The first thing we're going to look at with factoring is the greatest common factor, or the GCF. Factors are numbers that you can multiply together to get a product. And so when you're looking for the greatest common factor, you want to look for the basically the biggest thing that the problem has in common. So if you look at the first example, it says x squared plus 3x. You'll notice that both of those pieces have an x in them. And so here we would say the GCF is x. Once you take out the GCF, you write the leftovers inside parentheses. So x squared divided by x is just plain old x. 3x divided by x is just plain old 3. So our factored form would be x times x plus 3. If you want to check your work, you could distribute the x back into the problem, and that would let you know that you got it right. So x times x is x squared, x times 3 is 3x, so it matches the original problem. The second example is a little bit more difficult. So if we have 18x to the third plus 27xy, we're just going to look at each part of it. So first, if you look at 18 and 27, hopefully you'll notice that 9 divides in evenly to both of those. 3 divides into both of those, 6 does not. So 3 does also. The reason we're not going to use 3 is because it is not the greatest common factor. The greatest common factor would be 9. So in the front I'm going to write 9. Next, you'll notice that there's an x to the 3 and a plain old x in the problem. And so in this case, we're going to say that x is the GCF. Anytime you're talking about variables and GCFs, it's always the smallest exponent that you're going to use. Last, I can look at y. You'll notice the first part does not have a y, but the second part does. It cannot be a GCF if it's not in both pieces. All right, so I'm going to go ahead and put parentheses for my leftovers. If I look at the first part, 18 divided by 9 is 2. X to the third divided by x is x squared. So that's what's left over in the first piece. In the second piece, 27 divided by 9 is 3. X divided by x is nothing, it goes away, it's just 1, so we don't even have to write that. And then y doesn't divide by anything, so the y is going to stay as one of the leftovers. So that's greatest common factors. Next, we're going to look at the diamond method. The first thing you need to know about the diamond method is that the greatest common factor, that type of factoring, can always come first. So go ahead and write on that line, always check for a GCF first. So if I look at the first example, x squared minus 14x plus 40, there's no x in all of those pieces. The last piece doesn't have one. There's not a number that's in all of those pieces. So in this example, there is no GCF. So after that, we'll go ahead and do the actual diamond method. So if you guys recall, for the diamond method, this number goes on top, and this number goes on the bottom. And so we are looking for something that multiplies to 40 and adds to negative 14. Now, if you're not very good at multiplication, this could be a difficult thing for you to do. So if you go into your graphing calculator and graph the equation 40 divided by x, and then look at the table of values, then on the table, those are your options, the x's and the y's. So now if I'm looking at the table, I'm looking for something that multiplies to a positive 40 that adds to a negative 14. Then negative 4 and negative 10 would be the two numbers that will work. So negative 4, negative 10. Once you have completed that, now we can go ahead and write this out in factored form. So my first factor is going to be x minus 4. My second factor is going to be x minus 10. For the next example, if you look at those, the numbers are a bit bigger. I'd say anytime you have a number in the front, just double check to see if it's a GCF. If you look at this problem, you'll notice that all three of those numbers, 3, 45, and 168, are all divisible by 3. So in this case, we do have a GCF. The GCF is 3. So to start, I'm going to take out the 3. So 3x squared divided by 3 is just plain old x squared. 45x divided by 3 is 15x, and 168 divided by 3 is 56. So again, I'm going to set up the diamond. I'm looking for something that multiplies to 56 and adds to 15. And you can plug it in on your calculator to see what your options are. If you are good at multiplication, you might notice that the two numbers here are going to be 7 and 8. And so in my final answer with my factors, I have x plus 7 and x plus 8. And I cannot forget that GCF that I took out in the beginning. That has to go right in the front. Next, we're going to look at problems that you'll notice they look similar to the last examples we did. They're still trinomials. They have 3 pieces, but they're a little bit more difficult. So just like before, we are always going to check for a GCF first. So if you look at this first example, we have 5, 13, and 6. You'll notice between those 3 numbers that there's nothing in common. So now we're going to do slide, divide, bottoms up. And your teacher may not have taught you this last year, but I tried it with students in the past and they really liked this method, so I'm going to teach it to you guys also. So the first thing we're going to do is slide the 5 over to the 6. So 5 times 6 is what's going to go on the top of our diamond. 5 times 6 is 30. And then the middle term is still on the bottom, just like normal. So we are looking for something that multiplies to 30 but adds to 13. The two numbers there are going to be 10 and 3. So in our parentheses, we have x plus 10, x plus 3. All right, so we've taken care of the slide part. Now we have to divide. So next, what you're going to do is take that number that you slid over, which in this problem was the 5, and we're going to divide by 5. When you look at that problem, hopefully you're seeing that 10 over 5 can simplify. 10 divided by 5 is 2. And so now we can do the last part, which says bottoms up. So my first parenthesis is just going to be x plus 2. My second parenthesis, we're going to move the bottom up to the front. So 5x plus 3. Next, let's look at 14x squared minus 38x plus 20. When I looked at this one, I was thinking, well, 7 goes into 14, and I checked. It doesn't go in both of the other two. 14 doesn't go into both of the other two, but you'll notice that all 3 of those are even numbers, which means that you definitely have a GCF of 2 at least. And so 2 I found was the only number that goes into all of those, so I'm going to go ahead and take out the 2. So that leaves me with 7x squared minus 19x plus 10. So we're going to go ahead and do slide, divide, bottoms up. So we'll slide 7 to 10. 7 times 10 is 70. So we're multiplying to 70 and adding to negative 19. This is one of those problems that I use the calculator to do for me. So I graphed 70 divided by x, and then I looked at my table. And when I looked at the table, I could see pretty easily that the numbers here were negative 5 and negative 14. So in my parentheses, I'm going to write x minus 5 and x minus 14. And so I've finished the slide part, now I have to do the divide part. So I'm going to go through and divide each of these by 7, because that was the number that I slid over. 5 over 7 doesn't simplify, but 14 over 7 does. That becomes 2. And now I can do the bottoms up part. So bottoms up to the front. So this is going to be 7x minus 5. And this one will be x minus 2. And we cannot forget about that GCF that we took out, so I'm going to put that back down here in my final answer. And one last factoring type of problem that you've probably seen before is difference of squares. Again, we always check for a GCF first. So if I look at the first example, between 9 and 4, there's nothing in common. Only the first piece has an x, so there's no GCF in the first one to take out. Next, we'll remember that with difference of squares, you're going to have two sets of parentheses. One is going to have a plus, one is going to have a minus. It's called difference of squares, squares meaning that both of the terms are something squared. So if I look at 9, that is a perfect square number. It is 3 times 3. X squared is a perfect square because it's x times x. 4 is a perfect square because it's 2 times 2. So what I do is I look at the square root of each piece. The square root of 9x squared is going to be 3x here and 3x there. And then the square root of 4 is 2. So 3x plus 2, 3x minus 2. Next, let's look at the other example. Right away, I can see there's a GCF between 5 and 125. So here the GCF is just 5. So I'll take out that 5 and write my leftovers. X squared minus 125, just kidding, take out the 5. X squared minus 25, y squared, there we go. And now I can go ahead and factor that part. So I'm going to have two sets of parentheses, one with a plus, one with a minus. The square root of x squared is just x. The square root of 25y squared is 5y. 5y. And then I got to make sure I got my GCF in there at the end.